Okay, so I think I am expecting a few more to join, but in the interest of time, I will get started. So this session will be about system design of Google Lens. So Google Lens is a product which is launched by Google, which works on AI technology to detect objects. So before starting, how many of you have used Google Lens? Anybody in the room who has used Google Lens? Okay. So I will give a brief product intro of what Google Lens is, and then maybe we can get started with the system design. So as part of requirements, since this is not known to a lot of people, so let's go through what Google Lens is, and then we will start with the system design.
Did you know 30% of the neurons in the cortex of the brain are for vision? It's true. Humans process much of the world visually. Computers, on the other hand, don't. Or at least they didn't. Until recently, if you wanted to do a search for something you saw, you had to come up with the right words to type into the search bar. Sometimes it's easy. Purple flower, spiky leaves. But other times, we don't really know how to articulate what it is we're looking at. 4-person bicycle with thing on top? And that's where Google Lens comes in. It lets you instantly search what you see without having to perfectly describe it first. Look, it's a ruby-throated hummingbird. But how does it know? When Lens looks at an image, it pays very close attention to all the details. It notices shapes, colors, textures, and shading. But what's instant and easy for humans is actually very difficult for computers. Lighting and shadows can affect shapes and colors, which in turn affect the data Lens has to work with. And sometimes a muffin can look like a chihuahua, and a puppy can look like a bagel. Have you ever done one of those spot the difference puzzles? That's what Lens is doing. But it's actually more like spot the similarities. And instead of comparing 2 pictures, Lens compares 1 to about 15 billion to determine that this object is most like these other objects, which it turns out is a dog, not a bagel. But you don't always search something just to see more pictures of it. You want to know what it is. That's where the knowledge graph comes in, a collection of billions of facts about people, places, and things. The knowledge graph understands relationships between objects, so it can help us understand and label them. And in this case, tell you that this particular dog is called Finnish Spitz. Lens is always working to help you search in more natural and intuitive ways. Soon you'll be able to point Lens at something and ask questions about what you see, making it even easier to get help with objects in the world around you. We should always be able to learn about whatever we're curious about, even if we don't quite know what we're looking at.
Okay. So before we proceed ahead, did everyone able to understand what Google Lens does from that product demo? So Google Lens is basically an AI tool by Google. How many of you have gone to restaurants and scanned their menu using a QR, right? Recently, you would have seen that menus are all contactless, and generally you are served with a QR code that you need to scan, and then the menu opens up. So what do you use to scan that QR code, right? You can use any tool, including Google Lens. But what Google Lens separates from other products like any other scanner code is that if you point it to object, it can identify that object. It gives you an option to shop for that object. If you point it to a mathematical expression, then it can suggest you a solution for that mathematical expression. You can point it to a text, and then you can translate that text into any other language. Example, you are traveling in France and you don't understand French. You can point your camera, Google Lens app camera on that text, click an image, and then Google Lens will translate that to English or Hindi, whatever you are comfortable with. And it's a user input. So so these are the functional requirements, like text translation, what I said, from language translation, then text search. For example, something is written on a board, right? Let's say Buckingham Palace is written on the board. So today you have to type Buckingham Palace and then Google search. Now what you can do is point your lens on Buckingham Palace. It will detect that it is Buckingham Palace, and it will search. It will give you an option for you to click on search, and then it will do a Google search for that. So another is copy to clipboard. How many times it has happened that there's a question on a question paper and you want to search that question, and you need to type it, right? Rather than typing, you can point your Google Lens camera, select the area that you want to search or copy to clipboard, and then it will digitize that text into digital text, which can be copied to clipboard, and you can Google search it, send it to someone, share it to someone, and whatever. Second is mathematical equations. So if there is an expression given x square minus 3x plus 2 equal to 0, if you point your camera there, it will detect that it is a quadratic equation. It will go ahead and solve it for you. For linear equation as well, it will go ahead and solve it for you. But for any other complicated equations like differential or integral, it will scan that, understand that it is a mathematical equation, and with the right set of keywords, it will perform a search and point you to a very relevant article using reading which you can solve that equation. It doesn't solve all equations, okay? Only linear and quadratic, so far I have seen that it is able to solve. I'm pretty sure it will also solve 2 plus 3, 5 plus 2 and stuff. Another use case is shop an item from its image. So let's say you are traveling somewhere and you find a very cool jacket or something, right? And which somebody else is wearing, and you can just scan it, and you can check its rate on Amazon. And there is a shop button on Google Lens app that you can click, and it will take you through a bunch of shopping websites and detect and similar item prices it will show. Another is very important use case is food menu. So if you go to a restaurant, you get a menu. There is something it's written, let's say lasagna, and you don't know what lasagna is. So you just scan lasagna and it will show you photo of lasagna, how it looks like. Or if a foreigner is traveling to India and he doesn't know what dosa is, he can just scan the word dosa and it will show some images of dosa, after which he can order it if he likes. So these are, in summary, these are all the features which are offered by Google Lens today. Translation, search, copy to clipboard, homework, which is nothing but mathematical equations, shop, which is shop an item from its image, and food, which is get food photos from text or a menu. So any questions before we proceed ahead? Okay, good. So let's move forward. So now, before moving here, so how many of you are preparing for system design interviews, right? So from a system design interview perspective, we will take this session. So you are given a question, which I have explained so far, that there is a product called Google Lens, which has these 4 features. I picked this product because not a lot of you are aware about it, and that's what happened in an interview. You will be given a question of which the product you will be not aware of. I have given you 4 or 5 requirements, that these are the requirements I need, and now you need to design a system which solves these problems, and you need to give me a high-level design. So how do we approach such a problem? So firstly, you will talk with the interviewer and decide on the functional requirements and bottle down to some MVPs that you will be targeting. So in this case, our MVPs are these 4 things: text translation, search, copy to clipboard, solve mathematical equations, shop for an item, get food photos. And why it is important? Because any app will have some general issues like of sign-in, security, privacy. So these are things which are not MVP. What is MVP? MVP is the feature that the app is providing, the USP of that app, which is these 4 things. Okay, so that's the functional requirement which you have to talk with your interviewer and finalize on. And your session will be set up that at the end of your design, these 4 problems will be solved. There are some non-functional requirements which will not be provided by the interviewer. And these are things that you need to understand. Like if there is a Google Lens app and you are scanning a text, what do you expect? You want the app to be highly available, which means you open a camera and point, and then you should get back result. It should not happen that you are pointing and you're not getting anything. So that's availability, that your system has to be available for all requests anytime, right? It shouldn't happen that only from 12 hours it's working and 12 hours it's not working. It has to be available every single second. Okay, so that's availability. Latency, I should not wait for a very long time after I have taken a photo of something to get back a relevant result, right? If I took a photo of something and it is taking 10 minutes, then that's not a good solution, right? And third point is privacy, right? Like, what about the items which I am sending photos and sending to Google, and Google is giving me some results for that? What is privacy policy of Google? Are all of these data used by Google? Can I scan some private documents, some business secret documents as well using Google Lens, or should I avoid it? So these are some 3 non-functional requirements that you should come up with yourself and try to offer it in your app, in your system design, right? So far, any questions before we move ahead to the actual design? Okay. So as you have seen that if I am pointing my camera to an object and it is detecting an object, or it is able to identify what text is able to convert that object into digital text, then there is some machine learning algorithm going on, right? So now, given that, firstly, let's come to estimations. Like, what will be the requests that your system will be handling, right? So this is very important because before you design something, you should know how much request you are expecting, and depending on that only, you can decide what system will work the best, right? So since this is a Google product, and we know that Google is being used by so many people, but Google Lens is not that popular as of now. But still, we can expect that 1 billion requests are given per day. There are 9 billion people in the world. So it's a good estimate that every 1 in 9 is using Google Lens every single day. Okay. 1 billion requests are coming per day on the Google Lens app, which boils down to 2000 requests per second. Okay. You can do the math and you will get that it boils down to a little less than 2000 requests per second. And there are 2 to 3 billion active users of Google Lens, which these are the people who would have installed Google Lens. If you go to Play Store, you will see 100 crore people have installed, which is 1 billion people are active user. But when you design something, you don't design it for, let's say, next 2 years, 3 years, you design it for perpetuity. So for the next 5 to 10 years, how many users are you expecting? If there are 9 billion people in the world, and if your app is as great as Google, then you can expect 1/3 of them using it, not more than that. So 2 to 3 billion active users will be there. You will get 1 billion queries per day, which means out of your 3 billion active user, 1/3 of them are using this app every day, which is a good estimate because it's not something that you will be using every day, right? Unlike Google search, whose everybody is using every day multiple times. So if 3 billion active users are there in Google search, then the request would be of the order of at least 12 billion or something. But in this case, it's not. So you can estimate it to 1 billion queries per day, which is 2000 requests per second. Okay. Any questions so far? So for those who joined late, just I'll take you through the requirement that we are designing Google Lens and we are solving for 4 MVPs, which are text translation. Basically, if a text is written on a paper, then Google, and if you take an image of that, then Google Lens is able to scan that, convert that into a digital text and do a translation. It can do a Google search of an image of something written on paper. It can search it. If there is something written on paper, you can copy it to clipboard of your mobile, and then you can either send it to someone using WhatsApp, do a Google search or whatever you want. Second requirement is solve mathematical equation. If I have written x equal to 3 or x minus y equal to 5 or something like this, then Google search will detect that it is a mathematical equation. And for some set of problems, it will also give you the answer. And for other set of problems for which it is not trained, it will point you to a relevant document, reading which you can solve that mathematical equation. So these are basically for students, homework problems. If you scan integration problem, then it will detect that it is integration and point you to a relevant chapter. Third is very commonly used, shop an item from its image. If you find a jacket which is looking cool, somebody is wearing that, you can open your Google Lens app, scan that jacket, and then Google will show you matching items available on Amazon, Flipkart, and blah, blah, blah websites, and you can check out its rate. And if you want, you can buy them. And the last thing is food photos from menu. So if you are going to a restaurant of Italian cuisine and you see lasagna and you don't know, you have no clue what that is, or you have no clue what crostini is, you just scan that word and Google will show you food photos so that you know what you are going to order, right? So these are the functional requirements. One thing to note here, that all of these input is the image and output can be these four things. Either you will do a translation, search, copy to clipboard, or you want an answer for a mathematical equation, or you want to see that on an e-commerce website, or you want a food photo. But the input is the image. And from image, Google Lens is able to detect what that object is and give you relevant answers. Non-functional requirements, we finalized on 3, which is availability, latency, and privacy. Availability means that your system is always available, is never down. Latency means if you are taking an image, it shouldn't take 5 minutes that you're waiting for an answer. It should be instant. We can finalize on latency, which should be not more than 3 to 5 seconds in this case. And because we are okay, right? It is translating something, it is doing a big job. You can wait for 3 to 5 seconds and you're not expecting latencies in milliseconds here. And privacy is again important. For the items whose images you are taking and giving to Google Lens, what is happening to those images? Can you take private images of business documents yourself, your family members? What's the privacy policy of your system design? Can it work offline? That's one of the biggest questions. So because if it works online, then user is secure that he can turn off his internet and do searches, and he knows that his data is going nowhere outside his mobile, right? So these are some concerns which come with privacy. There are some GDPR issues which also come with privacy. The moment you want that all your data has to be deleted, Google will have to delete them. So these all come under privacy, which we'll talk about in detail. But these are the 3 non-functional requirements that we want to take. And then we did some estimations and we boiled down to that Google Lens will get roughly 1 billion queries per day, which boils down to 2000 requests per second. And next process is what other. So basically from an interview point of view, you have come up till estimations and now you will move forward to some more clarifying questions. Before we move ahead, any questions? Any questions? Any? Okay, so let's move forward. So other considerations, what other things that you would ask? So do I need to save images I process per user? So these are something that you don't know what the product does. So you can ask. So do I need to save images? Like, does a user expect that he has taken a photo of a text in France for which you translated it into English? Does the user expect that Google Lens will save that image and it's a response? No, Google Lens doesn't do that. Okay, so it's not expected. Now, it's very clear that if from an image, if I'm able to detect text, then that's not using traditional computing, that is using machine learning models. So do you train your ML models? Yes, we are training that ML model, which means that the images that users are giving, you will use that images to train your ML models also, right? So you may need to extract some feature from the image which users are giving to train your ML model to fine tune it, right? There will be some ML models already when you launch an app, but as and when user gives input, your ML model fine tunes itself, which we'll talk about how ML models work. But right now, you should have in mind that if an image is user is providing an image and has given consent to Google to allow to take photos, then Google should extract some images so that it can train its ML model. So, which is against privacy policy, but for now we are taking it as a go ahead because we want to improve our app. And we are saying that we will store your data in cloud. So you should not take any personal or private photos. Second is if the AI fails, which will happen. Let's say we saw in the product demo, right? A dog is curled up, can be confused with a bagel, and that's what machine learning fails. That's where machine learning fails, because it is not a deterministic algorithm. It is a prediction. It is always a prediction with some confidence factor. So what if your AI fails? Then how do I retrain my model, right? So if it fails, which means that the confidence factor of the result is less, then definitely you should save that image so that you can retrain your ML algorithm to fine tune it. Okay. And then how much space do I need? Because I'm saving all of these images, then in my system, what is the space which I will need? So as you know, there are 1 billion queries per day. So, and one image can be 4 KB, right? Google Lens can choose to not take an image of very high resolution because it doesn't need to take HD quality images. So 4 KB times 1 billion is 1 terabyte per day. Okay, so 1 terabyte per day, Google will have to store so that it can train its ML model and fine tune its algorithm. Okay. Second question, if it is taking 4 terabyte per day, then the next logical question will be that per day it is taking 4 terabyte, then for perpetuity it will be infinite, right? It is going towards huge data storage which we will not able to handle. But do I need to store previous day's data today? Am I using that in computing anything further? My ML models will be fine-tuned, not automatically, but they will be fine-tuned in the down, like parallelly by data scientists, and eventually they will replace the ML model in my system. So I just need to store the data in cold storage, right? So every day you will capture the data, which will be 4 terabyte, and then you will move this data to cold storage. Now comes the question, what do I mean by cold storage, right? So let's say a typical example that you have a user database, and if somebody is logging in, you are looking up on that database and allowing that login. So that is a hot storage, which means that will be used online, right? Anytime a user comes, in real time, you need to detect and allow him that access. But there are something which is called cold storage. Let's say user location, right? Which you are never going to use, but you want it for your business purpose. Tomorrow, a user logs into your website, you get his location, and you are trying to see which people from which locations are using your website. So this data need not be stored online in a very hot database for which you are paying thousands of dollars to AWS or Azure to keep it up and running in the real time. You don't need it there. You can store it as well in a file, in a notepad, right? So that's called cold storage. And the good thing is that cold storage is dirt cheap, right? S3 is not a cold storage, but any hard disk you can imagine is a cold storage, right? It's very cheap compared to let's say Cosmos DB or MongoDB that you are using in production, right? They are not only charging you for space, they are also charging you for the compute, which is making that database available every single second. So the good strategy here would be, because this data you are not going to use immediately for that user, you should dump it to a cold storage from where your data scientist team can use this data for where your ML models have failed or have succeeded and fine tune using this real data, because data scientists need data. We will come to that, how ML models work. But you should have this in mind that we are storing data, but we don't need to store it in a hot storage. We can store it in a cold storage like a hard disk or somewhere, because we are not going to use that in real-time computation. And the last thing is, are the results personalized? Which means if a person from India is searching for cat, then it shows image of an Indian cat. If a person from Persia is searching it, then it shows a Persian cat. But that's not the case. Results are not personalized in case of Google Lens. So you can take that as a no. So given these questions and answers, now you can start thinking of how you will design your system. But before that, let's understand, one of the main goals of this session is for you guys to understand that if a solution is using ML, so far we have done so many sessions on WhatsApp, Zoom, which were all deterministically solvable. We were using some networking protocols to solve it. But what if we are using ML models? So how do you deploy ML models at a scale? Firstly, let's understand how ML models work. So firstly, you need to have a good quality data set. Okay. You need to collect data for the problem that you want to solve. Let's say you are solving a simple problem that you write A on a paper and you have to detect that A has been written. So for this, you will need 1 million images of A written by different people using different handwritings, using small a, capital A, big A, Roman A, Persian A, whatever. You'll take all of that image and then you will write a ML algorithm, which you can forget about. ML algorithm is nothing but it is like it will see the previous data, it notes that answer, and then if you give him a new data, using the previous data and answers, it will try to predict which one it maps to, right? So ML model would look like, let's say, all the handwritings of 1 million people and and the answers for that. Okay, somebody has to go and write answers for that this is A, this is B, written on paper. This is C, which was written on paper. And using that, the ML model will train itself. And then if you write D on paper, then it will be able to detect, not 100% sure, depends on your handwriting, with a confidence score. It will tell that D with a confidence score of 99%. It looks very similar to B with a confidence score of, let's say, 1%. So something like this, a prediction is given by ML model always. So that's the training part, okay, which is done by data scientists, not by us. We are software engineers. We are preparing for a software engineering interview. We are interested in how to use these ML models to deploy them at scale. And once a ML model is ready, ML model is a very small algorithm, which can either have neural network or a deep neural network, or it can be as simple as some ML algorithm like linear regression or whatever. They are very small code. They don't use any database or anything. They are statistical code. You can understand it's like a mathematical function. Okay, you can think it of like f of n. And f of n gives you an answer. If you put n in that equation, n equal to 3, it will give you what 3 means. That's it. So it's a very small model. It doesn't use any database. It doesn't use anything. And then you need to deploy that at a scale. So this is what we talk about when we talk about ML. In more detail, you firstly collect and prepare training data. Then you choose and optimize your ML algorithm. Okay. So if I have to do a OCR, which is optical character recognition, which is A written on a paper, to, yes, this is the digital A, that is OCR algorithm. There are other algorithms, let's say that India is batting, and seeing the curve of India's run rate and who's batting right now, it tries to predict in the next 10 overs, what will be India's score, right? How many of you have seen that on live TV, right? It is being run from so many years, right? It is a very small statistical model which tries to predict that based on your batting of India and performance of each player in the team and his previous performance, what would India's score look like after 10 overs? That's prediction. Okay. There are predictions on who will win the World Cup based on this, which aren't always true, right? India's score prediction is never true, but it gives that score with a confidence of, let's say, 90%. I'm confident that India, if it is 200 in 30 overs, it will end up at 350 in 50 overs, right? 200 at 30 over, then it will end up around 300, 350 in 50 overs. That's what you also predict, and a statistical model will predict that with data point. That if in the lineup Dhoni is there, then it looks like it's very possible that India will end up with 350. But let's say in that lineup, somebody else is there instead of Dhoni, then it is more likely that India will make 320 or something. Or what is the probability that India will win if it has to chase 350? And right now India is at 200 in 30 overs, seeing the lineup. Okay. So these all can be predicted. And forget about this. Right now, if you're using a mobile device, then how many of you have seen that if you're talking about something and you see that ad, or if you are going to somewhere and you see ad of that place? So all of this are also happening as of now, that predictions are very accurate. So I can predict that using data, Google can predict that tomorrow on Sunday, where will you be going? It's highly probable that it will detect it quite perfectly because it knows that every Sunday you are going somewhere, let's say to a mall or somewhere, and it's highly probable that you will go that place again. So that's choosing the right algorithm. This is done by data scientists. We are not involved here, and they are experts in that. And these data scientists will come up with some algorithm which will be able to solve your problem. And whatever that is, we don't care. We just know that it will be a simple mathematical function which will solve that problem. Machine learning is entirely statistics. Okay. Second step, set up and manage environments for training. Now, a very big challenge of data scientists is not writing algorithm, but training them. Okay. Because ML models are not deterministically written. Like you are solving 3 plus 3 equal to 6. They will predict what 3 plus 3 can be based on what is 3 plus 2, based on what is 3 plus 4. It will try to predict, it may predict that 3 plus 3 is 6.5 with a confidence score of 99, because these are not deterministic algorithms. It will see previous data and try to predict what the new answer can be, right? So for them, it is very important that the quality of data is good. So they need to set up training environments where they can have and this is the very big challenge that data scientists face today, that they have terabytes of data on which they have to train a model so that that model can be correct, fine-tuned to real life use cases. If you train a model, let's say if you have only 5 inputs, 1 plus 1 equal to 2, 1 plus 2 equal to 3, 1 plus 3 equal to 4, and 1 plus 5 equal to 6. You have only these 4 items in your rows, four entries in your data set, and you try to predict what is 6 plus 7. Then it may tell you 6 plus 7 is 41 with a good confidence score. But you have a huge list of additions, right? And then the machine learning model will exactly understand what does it mean when we add, okay? Like humans, it will be able to understand what plus means, and 6 plus 7 will come out as 13 always. So quality of data is important. Data 1 terabyte of 1 plus 1 equal to 2 written billion times is not going to improve your ML model. We are talking about quality of data. That data has to be random. It has to be Gaussian distributed, right? So these all things play a very big role in quality of data. Again, these are done by data scientists. We are not involved there, but we should know what happens inside ML model. Fourth step, that you train and tune your ML model. So firstly, you ran on one data set, you got some result. You ran the same model on second data set, your accuracy deteriorated. So now you need to tune your ML model. You need to again retrain it with a bigger data set till a point that on a new data set, your accuracy is some X%, and that X% should pass the threshold. Like 90% of time you are able to detect correct, that's a good model. 99% you are able to detect something correct accurately, that's a much better model. And 99.99% you are able to detect something, that means you have reached perfection. So this is what is meant by train and tune. So these firstly is collect data, which is simply data collection, good quality data collection. Next 3 steps are done by data scientists. Now comes software engineers, which deploy the models in production. That the model that they have worked so hard to train them, tune them, how do I use it in production? Today, when I go to Amazon, I get a personalized view. When I log in, it predicts that, okay, Aditya, you should order this because you ordered an iPhone 6 yesterday. So you need a charger, right? Because charger didn't came with it. That's a prediction. Okay. Another prediction can be, okay, Aditya, I know from Google ads or Google data that you bought a car last month. So Amazon pays Google for that data, gets that data, trains on that data, and suggests me car seat covers when I open Amazon app. And that's a next level of prediction, right? Last is scale and manage production environment, which is how will you scale this ML model, right? So now let's move forward. Now let's move to how this actually works in, let's say, AWS. If somebody is using AWS today, how AWS deploys any ML model, okay? This is not solution for Google Lens. This is for any ML model. I'm just giving you a context that how does it work. So let's say you have a client application for which input is you scan a paper, handwritten alphabets are written, you scan one alphabet on that paper, and this client application is just taking an image and you're submitting it. When you're submitting it, it reaches, because Amazon is solving this, so you get to Amazon API gateway, right? Client is connected to a backend gateway, that's it. And that backend gateway is, we'll talk about what this Lambda does here. AWS Lambda just works as a webhook here, which redirects the request to the ML model endpoint. Okay, so Amazon SageMaker, now a brief context, Amazon SageMaker and similarly Azure Machine Learning, these are AWS and Azure solutions in which if you have a ML model ready, then within minutes, it will make your ML model work at scale. Okay, this is a solved problem. Now, if you are a data scientist, you don't need to search for a software engineering team. You will just prepare your ML model and you will go to Amazon SageMaker, and with a few clicks of button, your model will be available at scale at an endpoint. Okay, it will also give an endpoint to you. There will be some coding involved for which you will need 1 or 2 software engineers to help you out in that process. And so we'll talk about what that is. So let's talk about the first half. So here your ML models are there. Okay, your ML models are are inside some servers, compute servers, right? And they are behind a load balancer, and your load balancer is exposed via model endpoint. So imagine that my machine learning model for OCR is hosted at www.ocr.com, port number something, and some valid SSLs are there. It is not publicly accessible. It is only accessible to requests coming from my client application, but it is a RESTful endpoint. Okay, and it is hosted on some endpoint, which can be something like I said, www.ocr.com HTTPS. Now, when using a mobile, you scanned it, the front end application knows what backend application it has to point to. And that backend application will never be directly this endpoint. Rather, it will be some publicly exposed endpoint, because front-end code are never secure. So you'd never feed in IPs of your backend servers, etc. directly in your front-end code. They are always behind the API gateway. That's why API gateways are there, to make your API secure. Tomorrow, if somebody hacks your phone and sends 1 terabyte worth of data in Google just to crash it, then this API gateway will start throttling those requests. So API gateway has its own set of rules and purposes. So your endpoint is behind API gateway, and some publicly exposed IP is written in your client application to which it sends the request. And once your request reaches the API gateway, it basically calls a URL, which is a webhook. So AWS Lambda is playing a role of a webhook here, and it just has code of sending a response in a particular format, right? Your response has to be sent to your ML model in a particular format, right? Like I'm expecting image and some title of that image as input. And when I'm sending output, then also I expect in a particular format so that I can display that in my client application. Input output is very similar to the traditional front-end code, right? My ML model, whatever, or if a compute server, whatever is there, but input output has to be understood by your front-end code so that it can display, right? Output has to be at least be understood properly by the front end so that it can display the result. Otherwise, you will go in network tab and see the result. That's not how applications work, right? So AWS Lambda is playing that role here. It is playing the role of a webhook, which is redirecting the request to a model endpoint. Plus, it is also converting your image into some particular formats or getting some features out of that image, preparing a standard input which this model expects. And when the model gives a response, which is most likely as a JSON, then it transforms that JSON into something your client will be able to understand. So that's what AWS Lambda. So all the compute is happening on AWS Lambda, and you need one developer to work on this AWS Lambda, which can do the transformation of the input and output. That's it. And then the first 3 part, which is automatic scaling, load balancing, and model endpoint, these are all part of the Amazon SageMaker, right? So as a data scientist, you can get a model endpoint, but then you will need someone who will write the front-end code in client application and who will write the transformation code in AWS Lambda. Okay. And just with this, you will be able to scale your ML model. Okay. Any questions so far? Any doubts, any questions? So we have one question. If we are using cloud like Microsoft, okay, if you're using Azure, then Azure function would be an alternate instead of AWS Lambda. Instead of SageMaker, you will use Azure Machine Learning, load balancing, etc. You can look up what services are there. I think AWS has Elastic Load Balancing service, and similarly, you have Traffic Manager, I think, in Azure, and API Gateway, etc. are offered. These are standard offerings. You can just look it up what it translates to. But Lambda translates to Azure functions in the Azure world. Okay. So now these are all the context. Okay. We have one more question. Where is the actual ML code present in the whole architecture? Yes, here. These are all the ML code is present in the servers, which are these Amazon SageMaker, right? There in Amazon SageMaker, you can not only deploy, you can build and train your model as well. Similarly, in Azure Machine Learning, you can build and train inside the same tool, and you can also host it in a server. But of course, just hosting in a server doesn't solve the entire problem. You need the whole tech stack of a load balancer, model endpoint, Lambda API gateway, and then a client application as well. So your models are hosted on back inside your automatic scaling units. Okay. Let's see if there are any more questions. Thanks. Okay. So now these are all the context. Quick reminder, because this is a lot of things are new. Before we start the system design, now we have broken down. This was the problem which was given to us, that Google Lens is a product by Google which does these 4 things: text translation, search, copy to clipboard, solve mathematical equations, solve for an item from its image, get food photos from its menu. These are the 4 MVPs that we are targeting, and these are the only things that Google Lens does today. And then non-functional requirements you have to come up with in an interview. You need to come up with them. So these 4 you have to negotiate with the interviewer, that what problems you will be working on. And then these 3, from here on, these are all questions and answers asked by you. So these are the 3 things that we'll focus on: availability, latency, and privacy. We estimated that the load on our server will be 1 billion requests per day, and we will be managing 2 to 3 billion active users because this is a Google product. We saw some other considerations, which were like, we are not going to save images per process. There are no personalizations. We still need to train our ML models. We still need to improve our ML models whenever it fails. So we need to store the data, but we don't need to store all of the data. We will just store the data for that day. And the next day we will clean up that data into a cold storage, which can be a hard disk, which will be eventually used by our machine learning scientists to use this when they try to improve the ML model. Okay. But we don't really need to store this data in a hot storage. We will be storing it in a cold storage. Results are not personalized. And we saw how we will deploy ML. How do we deploy any ML model at scale? Okay. So now I will try to stop the screen share and start explaining 1 minute on using some pen and paper. Okay, let me know if you guys are able to see my screen. Is everyone able to see my screen? Yes. Okay, thank you. Okay, so let's start. So now the real design starts, right? So we have to make Google Lens, and we have requirements, which is text translation. Then we have text search. We have text copy to clipboard, right? Then we have detection. I'm breaking down the problem. So I'm breaking down for shop an item. So detection of object, and then again it becomes search. Basically, when you detect an object, you just search on Google, and you only filter the results which are from e-commerce, right? Search and filter from e-commerce websites. Then your mathematical expressions, that problem breaks down to again detection firstly of mathematical expression. And then again, search and filter. So once I detect that it is a mathematical expression, I digitize it and I search on Google, normal Google search. But now I will also filter for only results which are academic results, right? So search and filter. So here I am filtering on e-commerce. And here I will filter on academic websites. And the last one was of I think detecting food image, right? So food image again is detection of object. And then again you need to search. Once you detect that it is, firstly you all of this input is image. So input for all of this is image. So detection is prime for every single one of them. If something is written on a paper like dosa, firstly you need to detect that this is a text, this is not an apple, right? Somebody can also scan an apple, so in that case you need to tell that this is an apple. But if somebody scans a text on a paper, if dosa is written, so it needs to understand that this is a text, then it has to identify what that text is, then it needs to search that text on Google again, and then it needs to filter the results, in this case only for food. So Google search is already a service hosted, already available on Google, right? So, or you can simply think that once you, even manually, how you would solve this problem. Dosa is written, you don't know, you are coming from France, you don't know what dosa is, or let's say you don't know what lasagna is. So firstly you see in menu mein lasagna is written, your brain detects it. In this case, computer has to detect it. Detection happens. Then you type that in your Google search, that LASGNA, and then you get results. From that, you go to images and only look for food images. Lasagna mein agar, if there is a lasagna jacket, that you won't look up. So that's how you would manually do it. That's how even Google Lens does it, right? So it detects an object, it searches, and that it filters only for food. Your brain is much smarter, but machines are very dumb. So every single step has to be written to them. So if you see carefully, then all of these problems boil down into, firstly, detect whether it is a text or an object. If it is an object, then I detect that object, what that object is. Okay, that again ML algorithm will be used, which will tell you that it is apple, flower, bag, or whatever, right? It will tell you that with more details. So, but it is at the end of the day detection. And once you have detected what that is, then you will search that on Google, and using your search API, since we are making Google Lens, so you will have search APIs with you. So using that API and some filter parameters, you will only filter for food results for food, academic results for mathematical expressions, e-commerce results for anything that you want to shop. And for these are, we'll talk about them. So these are, text search is simple, like detect the text and do a Google search. This is one more step, basic. This is the most basic thing. Detect and just copy it to clipboard of your mobile app. This is normal, again, Google search without any filter, right? Text search. And translation is detection, and then calling your translation API of Google to get the answer. Okay. So these are the requirements, and these are the broken down requirements. Now, as a system designer in an interview, what would I do? I would firstly start with my clients. Okay. So these are my mobile clients, and these are all running Google Lens applications. And these all of them have given me input, which is a image. Okay, so all of them have taken one image and given to me. This is the input which I'm expecting. My service, now I'm doing the system design. So my service will be behind a load balancer. And typically you don't have one load balancer, especially for something like Google. You will have multiple load balancers, at least region based. For this case, we will only take two, and I'll explain what that means. This is your second load balancer. So basically, if requests are coming from, let's say, Asia, then you have one load balancer. If requests are coming from Europe, you have another load balancer. From North America, South America. So Google will have multiple load balancer, but for sake of simplicity, let's say there are two load balancers. There can be multiple, right? But you should know that load balancer can also be multiple. Okay. So there are multiple load balancers. So depending on where the request is coming from, it will hit some of these load balancer. Now behind your load balancer, what is there? So like we broke down the problem. So let's break it down into further. So we are seeing that firstly, we need, given an image, we firstly need to detect whether it is a text. If it is a text, then it boils down into these four problems. Okay. One, let's number them. So 1, 2, 3, and 5. These are text problems. 4 and 6, these are image problems. So even food, this is a text problem, right? Only one image problem, which is the shop, right? So all of these are image problems. And then, all of these are text-based problems. And only number 4 is a object-based problem, like general detection of object. You can add one more requirement, like if you scan Apple, then take an image of Apple, then Google Lens should be able to detect that it is an apple, and is a very basic thing like detection of object, right? So you can say that 4 and 7 are different than text search. Rest all are text search. Even mathematical expression is a text, right? So firstly, we will have a service which will decide that given an image, whether this is a text image or whether this is a non-text image, right? So we need a service that does that. So let's call that text identification service. Okay, so how do you identify something is a text or not? So let's say this service does that. Okay, so given an input, it will detect whether this is a text or not. Now, once it detects that this is a text, if it detects it is a text, then you have a OCR service, right? Like OCR is nothing but optical character recognition, which is a machine learning model. A very well-known machine learning model, which is available everywhere and anywhere. You can look it up on Google, and this will be hosted as a service. And once I have detected that what input I have, input image is a text, then I'll pass it to my OCR, and it will figure out, it will digitize that text. So there will be another set of requests coming from here, which will be, if it is not a text, then what do I need to do? Then I have a object detection service, right? Okay, something like this. If I can be a little bit more smart here and make this, rather than just detecting text, let's make it object detection service, which will detect what this object is. In case of text, it will say text. In case of apple, it will say apple. In case of photo of flower, it will say what flower it is. In case of a shopping bag, it will say it is a shopping bag. And if it is text, then I give my response to OCR. Otherwise, I will see what I have to do. But for the majority of my use case, my request starts from here, right? For others, I will have to design some other set of services. So far, this is the line in which I will be thinking. Now let's come back to my slides. Can you confirm if my screen is visible to everyone? Is my slides visible? Yes. Okay. So now let's come to how we will solve this. So now, similar thing, you can see that you have clients. Clients are sending image. You have a load balancer. And like I said, so before all of this, you will have a lens. So I did some rough diagram, but your original main thing will look a little different. So you'll have a lens managing service. Okay. Lens managing service is doing the input output thing for you, just like that AWS Lambda was doing, right? So this will take the request, this will convert into a proper input, and it will send the request to further services. But this is the one which will handle the request and response to your client application. Okay. Now, after lens managing service will just take the input. Let's say you have given input, then it will prepare a JSON of that image, and it will give the title of that image. It will also, in that image, it will give the time and probably the place also, because your application is giving all of them. And it will pass this as an input to your object classifier ML service, which is your object detection. So detection is called classifier in ML world. So your object classifier ML service can call your OCR ML service if it detects that it is a text. But you see that there is it will, if it is a text, it will call OCR ML service, right? Let's take it till there. We'll move forward for other cases. So if it is a text, now what can happen? If it is a text, then depending on what the input was, right? There were 7 types of input. So if it is just a text search, like scan using this image, do a Google search, then I will just direct it to my text search service, which will eventually call my Google search APIs, right? And it will call Google search API with some filters. Like if it is a simple text search, then it will call without any filter. If it is for food, then it will call with food filter. If it is for shop, then it will call with e-commerce filter. If it is mathematical expression, then we have solved it in a different way, and I will tell you why. So for normal text search for food, shop, and normal search, I will pass on my request to my normal text search service. But if it is a mathematical expression, now here it becomes a little complicated. So x square plus 3x equal to 2 and x square plus 3x minus 2 equal to 0. They are the same thing. And now your mathematical search service has to do some regularization of that expression. So after the OCR, it knows that it is written x square plus 3x equal to 2 or x square plus 3x minus 2 equal to 0. It will do some regularization of that expression, and it is very important. So for example, you know that whenever equations are written in a textbook, it is always written as a regularized expression. Like quadratic equations will be always written in the format of ax square plus bx plus c. And you have a high search hit probability if it is in this form. But if your expression is written like x square plus 3x is equal to minus 2 versus you are searching x square plus 3x plus 2 equal to 0, then your correct results, more relevant results will come with the second search. So that's called regularization of expression. Like take everything on the left side of equal to and then do a Google search. So, and this is something that you have to do. Actually, I have had an opportunity to work on a mathematical search engine. And this is one of the very basic requirement that given any mathematical search expression, you need to regularize. So this is only for like inequality, right? Like what about if it is greater than something? Then also there is a standard format. In integration also there is a standard format. So you standardize your expression first. For that you need a service on its own, right? It is a big work. You need to detect, then you need to normalize, take everything on the left side of equal to, and it gets more and more complicated when you talk about things like calculus, when we talk about things like linear programming and whatnot. So basically, this is regularization of that expression. And after you have regularized it, then you will again call Google Search API using this service itself. Okay, and you will only filter academic results. The third is translation machine learning service, right? So now you have detected a text, firstly, which was written in French. Now you have, the user has given you input that I want to translate this to English. So now you will pass on this request to your translation ML service. Firstly, it will detect what language that text is. It will detect that it is French. And second step, it will translate into whatever language the user has suggested. If he has suggested in English, then it will translate in English. If he has suggested Hindi, then he will translate in Hindi. Okay. So these are your 4 major steps. Now let's see. Now let's see that how it will work end to end. So let's say you have taken an image and of a dosa. Sorry, you have taken image of a menu in which paper dosa is written, and you are not from India, so you don't know what it means. You want to see an image for this. So your request will come via some load balancer. You are sitting in India right now. So it will hit a load balancer in India, which will most likely be hosted somewhere in Hyderabad, Bangalore, Delhi, Mumbai, right? And that request will firstly come to lens managing service. So lens managing service is a simple service. It will detect that it is an image. Iska format it will write ki, haan, this image was taken in JPG or PNG. Time was this, location was this, user is this, and it will pass on the input to object classifier ML service. Now object classifier ML service will simply see that this is a text, and it will recognize that this is a text and pass the request forward to OCR ML service. OCR ML service will see dosa written on a paper, and it will convert it into dosa digitally, paper dosa. And now you have paper dosa stored as a string somewhere as a variable. Now it knows that the user scanned a food menu and he has selected, give me food images, right? So based on your input, OCR ML service will divert this request to text search service, which filter with a filter of food. So now I will search paper dosa, and I will only filter out the food results. And I will get a bunch of images of paper dosa, and which are only food images. And now my user will see that, okay, paper dosa means this. So this is what I'm looking for to order. Okay, so this is roughly this solves the majority of your problems. Now let's come to the data part, the data training part. Okay. So whenever a request is coming to lens manager, let's say he scanned image of a dosa. Okay. Now, can you reiterate the responsibility of lens managing? Lens managing service is the service which is handling the request response. Firstly, it is handling all your scaling. It is handling how input will be given to the subsequent layer of ML services. It will handle how output will be given to the client once your ML services give you a response. So lens managing service, just like any other service, you will have a managing service. For any system design, there will always be a managing service which will take care of the input output scaling of your request. So lens managing service has these responsibilities. Okay. One more responsibility we will talk about right now. One more responsibility is that whenever a request comes of an image, and let's say this time it is the image. Okay. This time you have scanned an apple, which is very round for some reason and looks like a ball. So your lens managing service is dumb. It will just see, okay, JPG image, this user, this date, this place, forwards it to object classifier ML service. It detects that, okay, this is a apple, and it returns the response to lens managing service, right? This is an object classifier service, and user just wants, if it is not a text, user just wants what that is. Okay. If it is a text, then a whole bunch of game starts that give me this, that, and all. But if it is an object, then it just wants to know what that is. Like it is a red Kashmiri apple. That's all. Or it is a red New Zealand apple. That's the level of detail he will be interested in. And your object classifier ML service should be able to handle that. He's not looking for a Google search result. The guy knows that. Okay. So now object classifier ML service will detect that this is an apple, but this time, because the apple is surprisingly very round, so he will tell that it is an apple. Let's say it is a Kashmiri apple with a probability of 51%, confidence factor of 51%, and it is a red tennis ball with a probability of 49%. And then it is a New Zealand apple with a probability of 1%. Based on its shape and size, the ML model has given this response. Now, lens managing service will obviously not return 3 responses. It will only return 1 response, which is that 51% chances that this is a Kashmiri apple, red Kashmiri apple, and it will return that response, and user will be happy. Somebody who hasn't seen an apple knows now that this is an apple. Okay. That was a bad example. Let's say you scanned, instead of an apple, you scanned something which is not available in India, like a kiwi or something, right? Kiwi is also available. Something that you don't know what it is, a flower, a rare flower. You took a photo and gave it to your ML classifier, and your classifier gave you results, but the top result came with 51% probability. That's important. So now you know that there was something wrong with your ML algorithm because the confidence factor was very less, and it may be that you detected it incorrectly as well, right? When the confidence factor is such low, then it is very high chance that you have also detected it incorrectly. Like we were talking about in the product demo, that a dog curled up can be confused with a bagel. All of this can happen, right? A snake can be confused. A very far away image of a snake can be probably confused with a black thread or something. So all of these are possible with your ML algorithm, but the thing is that your ML algorithm will give results with a confidence factor, and that confidence factor, if it is less, then you definitely want to store those results in your daily storage, as we discussed, so that we can retrain our ML models. Yes, data validation transformation will be taken care. That's why this lens managing service is there, right? So all of this will be done by the lens managing service itself. The rest all are the ML layers. Okay, these two things are the ML layers. So lens, now let's come to, firstly, let's go through the design and then we will talk about more. There are some more enhancements which we'll do and we'll discuss about them. So now your lens managing service will also store the data, daily storage data. So there can be one approach that only store data whose confidence factor is, let's say, less than a threshold, which you can decide, let's say 90%. If it is less than 90%, then that data is a good data for you to retrain your ML model to fine tune it further. Okay, so these are the data. Let's say we came up with this strategy and we are storing anything and everything which is for which the top result is coming with a probability of less than 90%. So I'm storing it in the daily storage, then and there. It is a hot storage, which can store up to, like we did the computations. It has to store up to 4 terabytes. And there is a daily batch job which runs, scans this hot storage and stores this in a cold storage. Now, cold storage can be anything. Generally in Azure world, these are data lake. They are called data lake. They are not accessed using production. These are data lake, like this is cold storage, right? Amazon S3 can be a cold storage, right? Or your hard disk can also be a cold storage. So your batch service just scans this table at the end of the day, deletes everything and stores it into the cold storage. Now this cold storage data will be used by your ML algorithm services, which are your object classifier services, OCR service, right? Or your translation service to retrain themselves, to better themselves, because these are all the data for which the confidence score was much less. Okay, so your data scientists will be interested in this, and your data scientist team will use this data to improve the ML model, right? So this is the overall design. Okay, so now before we move ahead, any questions on this? Any questions so far?
The arrow from lens managing service to daily storage, shouldn't it be from object classifier ML service to daily storage? Because we are considering if the
you are right. So if the threshold part you consider, then yes. But my initial thought when I was making this design was that anything and everything I will store, right? But yeah, you are right that it should actually be from object classifier ML service and maybe also from OCR ML service if you want to also store the confidence factor for which the result was less. But yeah, I made it a little more general and I was storing anything and everything. And then because this is your live data set, it also has the importance of its own. So all of those where your training data says this data set has its own, you can sell this data, right? So anything and everything you can store it. If user has given consent, then this is a very pricey data. You can even sell this data. So anything and everything you store it, and then your data scientist team can figure it out in offline how to use it. But yeah, you are right. You can improve this design by also having arrows from object classifier ML service, OCR ML service, and translation ML service, which will also store one more parameter. What is the confidence score for this result, right? But looking backwards, it is good that you have it from lens managing service, because the response from ML service, OCR service, or translation service will also come back to machine lens managing service, right? So once the response comes, then it can do that addition. So I don't need to actually have arrows from object classifier, OCR, or translation service. Does that make sense? So when once the response comes back to lens managing service, I will do that and store that image with that confidence factor. So I think that's why this arrow is from. Right. So this is one design. So like I said, the
one question. Since you're saying 3 TB, 4 TB data, are you using any kind of a data lake for this one? Or are you using any kind of
so
NoSQL
the
database
daily, as per my estimations, daily data storage at max can be 4 terabytes. So 4 terabytes, this lens managing service is storing to a hot database, right? Lens managing service won't go to a cold storage and store it. The latency will be very, very high. So because this is real time, so this daily storage is a hot storage. This can be S3, which is both hot and cold type of storage. In Azure, this can be Azure Blob, but they are very costly. So 4 terabyte in Blob or Azure S3 is expensive. You can move this to a data lake using a batch service, which will run at one time every day. And it will wipe all your data from your daily storage and dump it into cold storage. Why it is not directly dumping into cold storage? Because directly writing into a cold storage will be a high latency thing, because cold storage are not highly available. They are just cold storage, right? So that's why we are using a hot storage for daily data storage.
Why do you need a batch service here? You can apply any kind of life cycle management policy by end of the day to move from there to here, right?
Any life cycle management policy will internally use a batch service only, right? Matlab, you are right. There can be. What do you mean by life cycle policy?
See, basically what happens if you go to S3, you define saying that, let's say you got 1 terabyte of data now, right?
Right.
So let's say what you are trying to do by end of the day, you're trying to move that to the from hot storage to cold, right? That's what you're trying to do here.
Yes.
So what you are doing here, batch service means here you would have written some kind of Lambda or some kind of a Python or something which will do that one, right? So there is additional work was there, correct?
Correct.
So instead of doing that, what happens? Life cycle management you apply, it automatically take care without writing anything.
I get your point, but I will add one more thing. Whenever you suggest your design in any company, you don't say that you will use Azure S3. You will say you will use S3 like or Blob like service. Why we do this? Because you are not, probably you may not use AWS there. You are using GCP there. Maybe that feature is there as well. Maybe that feature is in Azure.
It is there in all cloud providers. That's common. It is there.
The point is that it may be there, right? All of this may be also offered, like I was saying, there is the Amazon SageMaker service which also abstracts all of this. But when you are suggesting a system design, then rather than showing that how much you know about Azure S3 or Azure Blob, which is a good thing, you can mention both of them. But you should be able to break down the problem that, okay, this is a hot storage, it can be anything. Today you are using Azure S3. You are using Azure Blob.
Got your
point. You could use Elasticsearch also.
It is generic design you are saying. Got it. Yeah, makes sense.
Yeah, that's the only thing. So
fine,
in interviews, just don't show that you are coupled to AWS, so that interviewers feels that, okay, this guy is more suitable for AWS.
Makes sense.
Yeah, that's a better approach. And knowing internals are always good. So as and when system design rounds, the hardest question in system design would be design AWS S3. Design Google Lens means that some S3 is abstracted out. But if I ask you to design S3, that's a very hard problem itself. So if somebody knows internals of S3, that's a better candidate, right? If somebody knows how Kafka works, design Kafka, or design a simple Elastic cloud service which Amazon is offering. These are very hard problems to understand deeply, and experienced candidates are expected. This is not even expected from a 5 to 6 years experienced candidate. But as and when you will move further, so for principal interviews or for a senior SD interviews in these top companies, your questions will not be design Google Lens. There your questions will be design Kafka. Your question will design Azure Blob, design AWS S3. How is master slave working there? How is replication happening? And questions become more and more basic, and the more basic it becomes, the harder the design thinking is. For these, it is very easy to distribute into blocks and explain. So these are more like 8-year experience kind of candidate question. But when you move to 10, 15 years and you're interviewing for a senior or principal role, your depth is taken into consideration. Okay, but that's let's not digress. There is one more question. Cold storage, this remote, also photos and tags will be taken, or training and privacy. Yes, I'll come to privacy. Walls detection can also end up in correct generalization based on data. Cold storage is not remote. First thing, cold storage has no obligation of being highly available, has no obligation of latency or something. It has some obligation, but not very highly available or highly consistent. These are not expected. Cold storage is a cold storage. Now, your second question was that also the photos or tags will be taken by Google for training and so privacy. Yes, I'll come to that. That's a really good question. That's a follow-up question for which I will solve. False detection and wrong tagging can also return an incorrect generation. Yes, so for that, we are storing the image with a confidence factor. So if the confidence is 50% or a threshold, you can decide like less than 90%, then these are images which can potentially be incorrectly classified by your ML service. So your data scientist team's responsibility that look up your cold storage for the results which are poor and retrain your ML model and redeploy them. They will take some time, right? This is not an easy job for them as well. So they will fine tune their algorithm. They will read research papers. They'll take a couple of months to the new ML algorithm, which will now increase the confidence factor. Let's say that Apple was being classified as a red tennis ball with a confidence factor of 49%. Now the confidence factor of red tennis ball would be down to 1 or 2%, and 99 or 98% that this is a red Kashmiri apple. So that was the purpose of this. I hope this is clear. If not, let me know. Ashraf, I think you asked this. Okay, so but he pointed to a good segue here, which is data privacy, which was my next point. Okay, so now let me ask you one question. So you are an end customer of Google Lens. You are scanning all sorts of images. Will you scan, let's say, your offer letter using Google Lens? Let's say you got a printed offer letter. You want to save it. So you have taken an image and gave it to Google Lens. Will you do that? Will you have a confidence that Google will not misuse this data? No, you'll never have that confidence. Or let's say you are running a business and you have a revenue, you have done some whiteboarding. Okay, this is also a use case, which is not solved by Google Lens, but it is solved by Office, a Microsoft Office equivalent of Google Lens, where if you have drawn a table and if you scan that table using your camera, it will convert it into Excel. It's a great feature, right? But you would scan your holiday trips with that. You would scan your, let's say, split-wise bill of 2-3 people with that. But would you scan your company revenue data with that to convert it into an Excel? Will you have that confidence that Google won't misuse that data? How many of people here are saving passwords on WhatsApp or Google Drive? Are you afraid that Google might hack into your account? Is that a fear or not? Yes or no? Yeah, right. That's always a fear. Anything that goes online can be misused, can and will be misused. I will go ahead and say this. So if Google Lens wants privacy, then it will not come by saying that Google Lens will not misuse your data, blah, blah, blah. That won't happen. Okay, that's one level. Google Lens can give a statutory warning that we will save your data, we will not save your. So like instead of saving images, I will store features of your image, right? Apple, I'm not interested in image of Apple. I'm only interested in the features of Apple, which is input to my machine learning algorithm. So only those I will take. So now that may give you a sight of relief, but tomorrow your feature can be that take the whole input image. Basically, your image has gone to cloud, right? That's the main point of concern. So whatever you do, if you are running a multi-crore business, your revenue data will never scan. If you are a person, you will never take any private image or something. You will never try to do that, which you don't want to share online, right? So all of these concerns come. So the only way to get rid of this, and this is a good interview question as well, can you make Google Lens work offline? Can Google Lens work without internet? Because once my app works without internet, then my data is going nowhere, right? I'm just taking an image and it's not connected to internet, and I haven't given access for Google to sync my data to cloud, and now I am secure. So if you feel comfortable taking image from your phone of your revenue sheet, then you will feel comfortable to even use Google Lens in offline mode, right? Because offline mode, nothing is going to Google Cloud. Okay. So, and it can't go, right? Companies can't have apps that will sync all your cloud photos to all your photos to cloud unless you have given them the permission that sync all my photos to cloud, which most of your app does. But if it is working offline, it won't ask you for that permission itself. You can go ahead and disable that. Okay, only camera access you can give. Okay, you don't give gallery access. So can we make this work offline is the question. Can anybody think? How can we make it work
Yes,
offline?
yes, we can make, right?
Okay, what's the approach?
So approach is basically, I know I worked on this deep lenser in AWS. It works similar way. What happens? There is an option to containerize these models and send it to that particular device where that is running. I mean, on high level.
Great. Yeah, that's perfectly right.
That's the approach
Containerize the
basically.
models with
Yeah.
some data flow code that okay, this then this then this model, this then this model,
Yeah.
this then that model, and you make a jar file and send it to your mobile
And
application.
send it to typically this IoT devices, right?
Yeah.
They sits in somewhere, so IoT can run independently with these containers and they can send the data to the cloud. So
Correct.
that's where we can use this approach. Yeah, it works.
So that's a good approach. So, but what are the drawbacks of that approach? So firstly, the approach is that all your ML models, you will find a way to club it with some code of logic and send it to your client application. So when you are downloading your Google Lens app, then from that, you will not only just download the front-end application, your front-end application will also have your machine learning models containerized and some code logic, so that in offline mode only it is able to, your request is not going to any web server. But why aren't all apps built that way? So let's start enlisting the demerits. So the demerits firstly will be that you won't be able to get training data. That's the first demerit. High space, awesome. Your app will start taking more space, not just HDD space, hard disk space, also RAM space, right? Now it is doing much more job. If it is taking much more RAM space of your mobile, then what does it mean? It will drain a hell lot of battery from your mobile, right? And that becomes a very bad app. These are the kind of apps which users delete, right? Chrome is one such example, which doesn't run on mobile, but when it runs on mobile. I don't know what it does in mobile, but at least in laptop, it drains a lot of your resource. All of us have seen that, right? So the point is that if you try some sort of this, if you try to pull something like this off at a scale, then your constraints become that you are not getting user data, you are not getting your training data. Well, that's okay, because I'm solving privacy issue. So of course, I don't want the user data. So, okay, that's a soft point. Hard point is that I'm taking a lot of space, both HDD space, and I'm also draining a hell lot of battery of client. So that becomes a problem. Especially something like this will drain a lot of battery. Your ML model is running, it will use GPUs of your mobile. If you leave it running in the background, it will drain your battery in an hour or so. And that's why people don't do this. So if in an interview, somebody asks you this question that for some user or for some use case, I wouldn't want my data to go to cloud, then how will you solve this? Then a good answer here would be that you can have two modes in your app. One is online mode, where you are scanning anything and everything. And then there can be a go offline mode, where once you click on go offline, you don't need to turn off your internet etc. You can turn off if you have trust issues with that company. But go offline mode will not send anything outside your phone. No request will go to web server. But when you have clicked on go offline, then the processing happens inside your mobile application. But that doesn't happen every time. Only when you choose go offline and you want to, and this is a special use case, then only you will do it. And that will drain some battery, but not in all use cases, right? So that will make it a offline mode. Will thereafter download models from where time being before fully able to perform. Yeah, it will download as artifact when you are installing the app itself. It will not always keep downloading. And once your ML models are updated, you can push patches or updates to your application. And once you update your application, your new ML models will reach your mobile application. So no real-time CI/CD is needed. You can push patches to your mobile application and you can solve this problem. So turns out Microsoft has some tool. I'm not aware exactly of that tool, but Microsoft has this feature that it works online and offline. And yeah, that's how it works. So if you click on go offline, then nothing goes to their web server and everything is done from the client app itself. It does drain a lot of battery. So that's why user clicks only when he wants to go offline. Okay.
Another downside can be in offline mode, people can, try to decompile that jar file and try to get the logic out of it.
Yeah, but true. That's always there, right? That's always there, right? Your front end. But now your machine learning models are at this stage, right? So so for this is a solvable problem, by the way. Can you guess how this is solved? So the solution for this is any script or any business logic which you don't want to be exposed out. I'm okay if he takes the front-end code because there are so many front-end codes out there, right, on mobile applications. But if there is something which I really don't want to want anybody to use, then I encrypt that. Okay, so I can encrypt my machine learning models. Now, again, which means that I will get the key for that online, which means I'm not sending your image to cloud, but I am exchanging my public-private keys online. Okay, that is one solution, but that won't work if you switch off your internet. So if you want something to work by switching off your internet, then you are always at the stake of losing that classified information. So
will obfuscation work?
Obfuscation. Yeah, I guess all of that you can try. You can try all of that, but whenever you expose something at a client application, you are always vulnerable, right? Today you have made something, but some hacker can still hack your jar, right? Maybe a normal user can't, but somebody can still hack it, right? So that is always there. So there are many approaches to solve this. One is via exchanging keys, only the keys online, right? That's the best approach as far as I know. Second thing is that the ML models that you will send to client will be different from the ML models which are deployed on your server. Firstly, because you will try to give a lightweight ML model to your client, right? You don't want to give a very heavyweight ML model which uses all their resources. So this ML model accuracy and performance will be much bad than the online algorithm. And you are also okay if this gets compromised. If somebody is able to take it, then take it. Okay. So that is always there. Maybe I won't be able to do, maybe you won't be able to do, but some hacker sitting in Russia will be able to do. Okay. Somebody can hack into your client application is always vulnerable. You don't know how that is going to be used. So you never give any. In this case, what goes at stake? Nothing, right? It's a statistical ML model, nothing else. I'm not giving information of my IP or anything which will put my company into vulnerability. I'm only putting my lightweight ML models into vulnerability, which I'm okay with. Okay, take that. Right. The real money is in the the hosted ML algorithms, right? Because their accuracy and everything is top class.
So, but that is also, what happens even though your ML model behind the scene, the load balancer will be there, right? Is that correct? And when you send it offline also, no load balancer.
It's on your client app, right? Where is the load balancer now? Nothing is there. Client app is working, nothing is there, right? It is completely inside your mobile now.
Even client app also, they should be calling some gateway or API to invoke this ML model, isn't it? They cannot run independently, correct?
No, they can. So that's what I said, right? So when you containerize and send something to client, then it is working completely offline. So now you have written that's what I said. You containerize all your ML model and you write a small code which tells you the logic, okay, send this data to this model first, then this model, then this model, and this is the response. So all of this goes as a package of your front-end code, the client application. And no request, nothing comes to any of the Google web servers. So now when you take image of an apple, then it inside the client application only, it will take you through 2 or 3 models and it will tell that, yes, it is an apple, or no, it is a red ball, right? That was the design in completely offline mode. Nothing is coming on the web server. Because once the request comes to web server, then the whole purpose of privacy is beaten, right? Once the request, which has your image, reaches Google server, then you don't know what Google is doing, right? That's the reason why we try to solve the problem of privacy. If you have taken a photo of your offer letter, you don't want that image to go to my web server, right? I don't know what I will do with that. Maybe tomorrow Google sells this data to the negotiation companies and you are not able to negotiate a good salary, right? Or now Google knows your salary. So now it will pitch you those kind of ads. So does that answer your question?
Yeah, fine. What I'm saying, I mean, I don't know whether in this case that scenario, but to handle this, right, we can, there are many things, right? You can do the customer key encryption, or you can also add some kind of when you have the model, right? Typically, when we expose model to protect these kind of vulnerabilities, DDoS injections, SQL injections, and all, we can add some kind of WAP layer, and which will restrict which IP address should come from. So
those are yes. So that's what I said.
Some kind of alternatives where we can achieve to solve these security issues when you expose
security issue offline. On web servers are already solved. Now you are trying to solve security.
To the offline mode, yeah. That's why I'm thinking that angle. I'm thinking that angle to apply here as well. So
that's what I said. There you can try multiple things. The best approach is that you exchange public and private keys online and don't send any user photos. So what you can do is you can encrypt your ML models using a private key, and then you can send and then you can have public keys exchanged over the internet, and your client will be able to figure out what that model is only after exchanging that public key over the internet, and it will not send any image to my Google server. But still it won't work without the internet, right? That keys exchanging is at least that is happening using internet. If you want it completely offline, right, then anything and everything that you are giving on as your client jar is compromised. It's already compromised. Your Make My Trip application that you have downloaded in your mobile, you can, maybe I can't read it, maybe you can't read it, but there will be some person in the world which will be able to decipher everything out of it, right? So that is always vulnerable. Anything and everything that you push to client side is always vulnerable. So you have to be very careful what you are sending. So that was the point. For offline scenario, will there be accuracy issue? Like, yes, accuracy will be poor. If you want to improve the accuracy, it will drain more and more battery. Of course, it won't be as, so these are lightweight ML models. So that's expected, right? You want privacy and you want performance, everything can't come. And that's the incentive, right? That's why Google will also want that the performance is bad, so that you push that data to cloud. And once you push that data to cloud, Google will sell your data, right? And that's how, because these apps are free. So how they are paying themselves, right? You should think that also. Because Google Maps is free. It is selling your route data, right? It will pitch you ads of the shops for which the routes you are taking, right? Tomorrow you will get those ads. So if the service is free, then you are the price, right? Your data is the price.
One question: how to synchronize the data? In offline, basically, it's all working within the device, right? Because that data has to be synchronized with our online data.
In this case, there is no synchronization, right? There is no personalization. There is no synchronization. You take an image, you get an answer. Your question becomes more and more relevant when things persist, right?
Correct.
Storing user level details. I am not.
Yeah.
It's part of requirement. I made it clear.
Okay.
Okay. So now we know how to handle privacy, right? We can have offline and online mode. Now ML model in backend client versus backend server, we discussed pros and cons. And this is always a good discussion to have. You can't have a completely mobile client ML model hosted solution. And because of privacy issue, completely backend server hosted also doesn't work. So you need to strike a balance somewhere in the middle, offer an offline feature for those who want. And that turns out to be the best solution in this case. So that's all I had.